Welcome to lesson 15 of 20. Have a go at this in your own time. The question you can see at the bottom. See you in a minute. You may have said not possible. If you did, you're correct, but please wait. Don't skip ahead because there's something interesting about this. How many variables are there? 1, 2, 3. And there's only 2 equations. So in theory, not possible to solve. But actually, that's just kind of a rule of thumb. Because we already know that sometimes you can solve equations. Solve for variables when there don't appear to be enough equations. It just depends. Sometimes it's possible. So let's have a look. Let's rearrange this equation here. I'm going to write it as a minus c minus b. I'm switching around the b and the c. Spot something? Choose different colour. Got a minus c here. Oh, and this is a minus c, and we know that a minus c equals 3, so we could write 3 here instead. So I could now, let's just do some rearranging. Add b to both sides. 3 equals 11 plus b. Minus 11 from both sides. And that gives me minus 8 equals b. I'm just going to switch it around because I like having it around the other way. So we can at least find out what b is. It's not possible to find the others, by the way. There you go. So that's kind of interesting. If you said not possible, I'm going to say nice one. Good work. Solve. Have a go at this, and if you get really stuck, hit play again, because I'm going to give you a clue. So there's going to be a clue, then another opportunity to pause, and then I'll actually give you the answer. Right, my clue is, I'm going to write out the clue. Make look the same. That's not very good English. I'm just being lazy. There should be an it in there really to be grammatically much better. Make it look the same. Can you make it look the same? So pause the video, have another go. It's still pretty tough though. Right, here's the thing. I look at this and I think I'm like, I'm gonna have to try and make it look the same. I don't know any other way to solve this particular equation. There's a 4 here. Well, and there's like an x. The moment I see an x, I'm like, well, I'm kind of stuck. I can't change the 4. So, but can I change these 2's into 4's? Well, let's just start playing around, shall we? But the left-hand side is 2 times 2 times 2 times 2, because 2 cubed is 2 times 2 times 2. Oh, wait a sec. What's 2 times 2? It's 4. 4 times 4 is 4 to the x minus 0.5. So 4 squared is 4 to the x minus 0.5. So now we can do by inspection. And we can say 2 must be equal to x minus 0.5. I'll add 0.5 to both sides. And I end up with 2.5 equals x, which I'll just write around the other way because I prefer it like that. There we go. There's the answer. Let's do the next question. It's a plot, which I'm going to cross out and write a sketch instead. And I've just managed to zoom. Oops, hang on. See if I can get this right. Whee! Right, let's do a sketch. So there's 2 questions to try. I'll just draw some axes. I'm labeling the axes like this. I need to show which direction the positive values are. I need to label the axes so we know which one each is, and we need to label the origin as 0. I'm giving the answers now. Move on to the next question if you're happy. I'm going to talk through the one on the right hand side first. Remember that this is the line y equals x. And if we're doing the line y equals x plus 3, I'll just circle that in green so I think it makes it clearer. All we're doing is we're adding 3 to each of the y values. So the y value is increasing by 3, which means it's going up 3. So the whole thing is raised by 3. Exactly the same thing applies here. That is the line y equals x squared. The other line is merely the line y equals x squared with 3 added to it, which means that each y value is increased by 3, which means the whole thing is raised upwards by 3. Let's do a solve question. Have a go in your own time. So the answers are q equals 0, or q equals minus 10, or q equals minus 1. I'll go through my answer. How do we factorize? Oh, right. Big picture. Oh, there's a q squared, a q cubed, a q squared, and a q. And there's only one equation. It's three different things. Not possible. So you might have said not possible. If you said not possible, it's a good answer, but let's look at why, in fact, this is one of the situations where, in fact, you can. How do we factorize? Because basically, factorizing is a key way of solving equations like this. The first thing we do is try and find something that that is in common everywhere. Oh, look, they've all got a q. So we can take a q outside and we end up with q squared plus 11q plus 10. And then we try and repeat that. Okay, there's nothing else inside. And then the second thing we do is we try and do double brackets. Okay, well, let's try that. Right, so q times q is q squared. How do we make 10? Well, it could be 1 times 10, it could be 2 times 5. Well, to me, it's obviously 1 times 10. Because that's how we get the 11. You can multiply out all that kind of stuff and check it. Oh, look. Do you remember when we did PQR equals 0 and we solved this? And we said that P equals 0 and or Q equals 0 and or R equals 0. Notice that we've only got ors here, and that's because it's all Q's. It's all Q's, and Q can only be one thing at a time. Okay, anyway, let's have a go. So we're going to drop our lines down, and we're going to say Q equals 0, because one of these three things must be equal to 0, or Q plus 1 equals 0, for them multiplied together to make 0, or Q plus 10 equals 0. So we've now just got three things to tidy up. Well, that's immediately giving us the answer here. Let's minus 1 from both sides. That means that Q equals minus 1. So that gives us that answer there. It's minus 10 here. Oh, did I write that wrong? I meant to write 0, sorry. So then Q equals minus 10. There we go. So that's all the answers. Let's have a go at the next question. This is a calculate question. There's a whole bunch of calculate things. So I'll let you know when I've written them all down. I've written them all down. Have a go in your own time. I'm writing down the answers. Now, I know that I've been a bit lax with the positive and negative answers to roots, which, anyway, it's just a thing in this series of 20 lessons. I've been focusing on it less. But we're just going to be very aware of it here because it's important within the context of this question. So jump on to the next question if you're happy. Otherwise, I'm going to talk about this a bit. Well, the square root of 64 is 8 because 8 times 8 is 64. Now, here's the interesting thing, but it can also be minus 8 times minus 8 is 64. What about this? What's the cubed root? That means that 4 times 4 times 4 is 64. But minus 4 times minus 4 times minus 4, well, that's minus 64. So that one kind of moves over here, which is why this one has an answer. But then when we're doing a sixth root, that's an even numbered root, and 2 times 2 times 2 times 2 times 2 is 64. But minus 2 times 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 minus 2, well, that's also 64. Which is why we then end up with not possible, where it's an even numbered root trying to get a negative number. So there's some thoughts there, and just generally just a bit of practice. Just do another calculate, and I'll let you know when I've written them all down so you can pause the video and have a go at them all. That's supposed to be -3. Have a go in your own time. See you back here in a second. Right. I'm going to write the answers out, which is going to be difficult because things are starting to get a bit harder. Right, that's it. Now, I'll skip ahead or I'm going to talk it through. That minus means flip. So if we just scribble out the answer from it, so that means we end up with 2 over 1 to the 3, which we can just write as 2 to the 3, you don't need the over 1, and cubed, the 3 means cubed, so it's 2 times 2 times 2, which is 8. This one's interesting. That squared is actually on the bracket, so we write the minus, and then we start the open bracket, and at this point, that's when we have to do the timesing. So it's just -1 times 1, which is -1. Does that make sense? So you're squaring what's inside the bracket. That minus on the outside, that's not getting squared. That just sits there the whole time. That just sits there watching while the 1 gets squared and it's still there at the end. However, in the next one, the squared is actually on the bracket, so you get -1 times -1. Oh, look, which is +1, because now the minus is being squared. Next one, again, I'm convinced here that it's a good idea to keep scribbling out the answer and redoing it. We don't need to worry about, the 1 doesn't have any effect. The minus is just flip, but we can't flip it, so we need to make it 8 over 1. So now 8 over 1 flipped is 1 over 8, and that's the answer. This one again, we need to make it 8 over 1. We flip it, makes it 1 over 8, but there's still a third. What does the third mean? That means cubed root. So it basically means what's the cubed root of an 8? So it means what times what times what equals an 8th. But you know what? I like to draw it like this. So then you can think about it as what times what times what makes 1? Well, 1 times 1 times 1 makes 1. And what times what makes 8? Well, 2 times 2 times 2 makes 8. And that's the final answer. Let's do the next question. We've got a true or false. Which I often use a lot more when I'm teaching one-to-one or in a kind of real life situation, but because I'm teaching via video, I'm not using this too much. I'm not using true or false very much. But in this case, I think it's quite useful. I don't really know another way of kind of leading gently into learning this topic, to be honest. I find this is quite effective. So have a go in your own time. So, true or false? True. 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 Right, there you go. I'm now going to double check them. I just tried to do that in my head. Now, we know that the square root of A, square root of B, is the square root of AB, yeah? So, that would be the square root of 6, because 2 times 3 is 6. And then 6 times 4, 6, 12, 18, 24, makes the square root of 24. So that one's correct. Similarly, we can just ignore the 1, because 1 times anything is just itself. And 2 times 3 makes 6. Because remember, the square root of A, square root of B, is the square root of A times B. And to reword the first one, in case you're still staring at the first one, think of that as the square root of A, square root of B, square root of C is the square root of A times B times C, which must obviously be true if AB is A times B. Then this final one, let's just get rid of this. What's the square root of 2 times the square root of 8? Well, that's the square root of 16, because 2 times 8 is 16. And the square root of 16 is 4. There we go. There's a bonus lesson on this topic. I'm just trying to touch on this topic, not really going into it in too much depth in these 20 lessons, but I think it's something that a lot of students just like to have a little mini grounding in, just so it at least feels familiar. So with this and with some of the other things we're doing in these 20 lessons, some of this I'm repeating over and over again with the aim of you being able to do it yourself confidently. And some of the topics we're gaining familiarity with them, just so that you're getting to the point where, oh, maybe next time I encounter this topic, I'll really get my head around it and I'll be able to do it. Okay. Have a go in your own time. And the answers are 7 and 7. Because whatever's in here, the answer's just 7. There you go. We haven't done this for a while. Let's do same to both sides. Well, we kind of have been doing it because we're constantly doing it, aren't we, in the questions? Like built into other questions. But I just want to do it overtly, clearly on its own, just to again spell out what this technique is. I'd like you to first of all do a +2, and then I'd like you to do a divide by 5. And just see what happens if we do those two in a row. So have a go in your own time. Right, so if I add 2, I end up with 5x minus 2 plus 2 equals 0 plus 2. Oh look, the minus 2 and the plus 2 cancel, so I've got 5x equals 2, because 0 plus 2 is 2. Now I divide by 5, so I end up with 5x divided by 5 equals 2 divided by 5. Oh look, the 5 on the top cancels with 5 on the bottom, so x equals 2 over 5. We've just solved that linear equation. Next question. Factorize. We know how to factorize now, so whatever this looks like, just be patient and just follow the standard technique of the two-step technique of how to factorize. Okay, so have a go in your own time, just steady as she goes. What's the first thing? The first thing is we take something out. Oh, they've all got a y. And then we repeat. Is there anything else they've got in common? Oh, I missed it. They've also all got an x, so I could write xy, and that just leaves me with an x plus 5x plus 6. Here's the important thing. Oh, I didn't notice that. I could simplify. Oh, look, so that makes 6x. So I've now got xy, 6x plus 6. Oh, so I can still take yet another thing out. I can take out a 6. 6xy times x plus 1. That's the final answer. If you're patient, carefully work it through, things can go well. Let's do the next question. Simplify if possible. Because I like to have not possible as a possibility. That was a weird way of saying that. Have a go in your own time. Right, I'm going to say not possible. However, you might have done this. You might have said, well, I could do this. Because the denominator is the same, so I can just combine them. Yeah, but here's the thing. It starts getting very debatable whether you've actually simplified it. So, in this case, I'd say both are good answers. Let's do another simplify if possible, and this is the last question in this lesson. Have a go in your own time. Maybe you just did this. Oh, by the way, the answer is not possible. Sorry. The answer is not possible. Maybe you just did this, though. And you thought, well, I factorized it. Surely that's simpler. Just like the previous question we just did, highly debatable. Maybe that's simpler. It doesn't really matter. I wanted to just touch on those last two questions just to address, because I know that a lot of students start at some point when they're doing simplifying, they start thinking, wait, what does simpler actually mean? Well, combining fractions doesn't necessarily make it simpler, although sometimes it means you can cancel things. And factorizing doesn't, unless it then means you can cancel things again, it doesn't really make it simpler. But it depends. You might have a particular exam, you have to do a certain thing. See you in the next video.